Hey, good morning. I'm glad there are lots of parallel sessions running. I'm glad you chose our session. So my name is Arun Gupta. I work for Red Hat.
I'm Qvarnström. I also work for Red Hat.
All right, very cool. So today we are here to talk about DevOps with Java EE. How many of you are doing DevOps? Oh, wow. Yeah, that's the kind of hand I wanted to see. All right, that's what I've heard most of the times. How many of you are using any version of Java EE in your daily life? All right, that's most of you. Excellent. OK, cool. Well, let's start with this.
So, my name is Qvarnström, as I said. I work as a technical marketing manager at Red Hat. I've been working at Red Hat for about 7 years. I have a background as a developer and architect, but I also worked a lot with the operations and making operations effective and streamlining and automating all the deployment around Java EE, etc.
Right, and my name is Arun Gupta. I work for Red Hat. I'm not that old at Red Hat. I'm about a year and a half at Red Hat. But I've been in the Java EE land. I was part of the founding team of Java EE at Sun, then Oracle. My last gig at Oracle was driving the Java EE 7 launch. And for about 10 years, I've been a developer advocate. Now I run the technical marketing team and developer outreach for JBoss middleware at Red Hat. Compulsive blogger, so a lot of content you will find on my blog. And then we are always accessible. Red Hat, we truly believe in sharing and accessible and transparent. So shoot us an email and talk to us about that.
Sure. So the agenda we're going to go through today is what is DevOps, and talk a bit, give you a bit of background what we think about DevOps and what the challenges are, etc. And then we're going to talk a bit more about Docker containers and how that can be used together with DevOps. And then we're going to talk about testing, Java EE, Docker, using Arquillian Cube. And last thing we're going to do is talk a bit about how we can do DevOps using Java EE and Docker. How Docker can enable basically Java EE and DevOps.
And demo guards and network permitted, we might be able to show a real demo of that as well. So what is DevOps? Depending upon who do you ask, oh, I've been doing ID operations for 20 years, or we've been doing DevOps forever. Oh, I've been talking to my IT guy for 20 years when we produce the code. So we have been doing DevOps for every year, for all these times. So depending upon who do you ask, the definition of DevOps could be very different. People talk about we have a DevOps team. That's an oxymoron right there itself. Now, there is no such concept as a separate DevOps team. So understand that. And I mean, if you are an IT guy, don't call yourself as a DevOps guy. DevOps is really a mix of dev and ops working with each other. There is a concept of no ops, which we'll talk about briefly, to support the entire DevOps movement. But if you're calling yourself as a DevOps guy, I see this job posting saying I'm a DevOps engineer, or I'm going to do this DevOps. So I don't really get that point. To me, the simplest definition of DevOps, as I see, is defined by this DevOps manifesto, so to say. Now, manifesto in general has an evil connotation to it. But if you look at this DevOps manifesto, this was done by Jez Humble, the guy behind the book on continuous delivery. Here are a bunch of points he has listed over there. If we start going with them one by one, the biggest focus of DevOps is really to have, as a reaction to poor communication between developer and operations people. That's really the biggest focus over here. In general, the developer will build the product. When I say developer, I really mean product management, engineering, all those guys will build the thing together all the way up until 80%. Once it's done, they're going to throw the war file or something over the wall to the ops guy and then go let them figure it out. It's their problem, not mine anymore. Then, because they're working in their own silo, it's like, I'm going to put my blinders on. I'm the developer. I know what's best to do. They're going to keep working in their own land. And then they're going to talk to IT towards the end of the cycle. So really, that cross-communication or cross-organizational communication is one of the most important aspects of this whole movement. And again, I'm using the word movement very clearly. A big focus of DevOps is, you don't want to tell somebody that, oh, when you deploy the war file, make sure you create this JMS resource, deploy this JDBC driver. No, that's not the focus. The focus is 100% automation. Anything less than 100% automation is suboptimal. Anytime you introduce humans, which have feelings, which are hungry, which get grumpy, the process is going to get screwed up. So 100% automation over documentation. That's exactly what your focus is. A lot of it is about self-service infrastructure team. So as I was saying, there is a concept of no ops. There are a lot of different concepts that are common to DevOps. So you want to have scalability, you want to have service replication, you want to have a PaaS, all those concepts. But all of that has to be done in a self-service infrastructure. So my favorite company that I like to quote all the time is Netflix. In terms of Netflix, Netflix runs on Amazon, 100% completely automated. Any engineer can release any feature at any point of time. And they have the visibility, they have the ability to provision 5,000, 10,000, 20,000 Amazon instances any point of time. So that's no ops team has given that ability. But as a Netflix engineer, you can go to a portal and say, hey, I want to provision, or maybe a script, say, I want to provision 5,000 instances, I want to release my feature. And how it's going to scale, all that is pretty much automatic in that sense. So I think that's sort of one of the key functionality. Again, automation over documentation is an important aspect. And last but not the least, as a development team, your job is not done once you say 1.0. As a matter of fact, your job is basically 25% done, or maybe lesser done when it's 1.0. Your job is done only after the whole product is retired from the production itself. All the way from conception down to the actual last production issue until it is resolved, it is your job. That is basically DevOps. And you're not really looking at a development team. It's basically, as I said, dev and the ops guys working together hand in hand. And that's a serious definition. It's like, how do I get it? But to me, really, DevOps is about boomerang kids. You have grown up your kid, you've given all the nice things to them, you put them through a good school, the kids leave, that's your release 1.0. You don't want them, in 10, 20 years later, them to come back to the home, live with you, with a wife, with 3 kids, and a dog, and a pony. Well, that's how your product should be. Once you release the product, it should go out, it should be able to live happily by itself, as opposed to coming back, with issues every 3 days. Oh, Dad, I need more money. Oh, I need a car. I need to get married. I need a job. I need to buy a pony. Not like that. So make your product solid enough so that when it goes out in the market, it can live by itself. Of course, it's software. So there will be issues, but it should not sit on your side.
I think one important thing for that is continuous improvement as well. Same thing goes with your kids. You have to continuously improve them to be better and better so they can stand on their own legs.
So what we like to call as 5 C's of DevOps. So that's sort of the fundamental concepts. And we're not going to get into the details of DevOps here. There are lots of brilliant talks on DevOps. We want to focus on the DevOps and Java EE using Docker over here primarily. So if we go with the 5 C's of DevOps, the first one is about collaboration between dev and ops. So as I said, in that sense, dev is anybody who is building the product. Product management, product engineering, QA, all those guys are on the dev side of it. Ops, on the other side, is anybody who's providing the infrastructure. So IT guys, network guys, security guys, third party, DNS, proxy, firewall, all of that together. So really from the conception stage, when you say, oh, this is my job this is the goal of the product or the project, both the guys need to work together. Is it going to scale? What are the scalability issues? If it's going to scale, how many instances am I going to need at the runtime? Can the ops really help me with that? If I need to test it to scale it at that level, can ops give me that self-service infrastructure where I can scale? So all those things need to be discussed early on as opposed to saying, oh, we're going to think about it. Let's build the product and test it on for 2 or 5 or 10 concurrent users, even though the eventual goal, you will possibly see, who knows, 100,000 concurrent users. So those things need to be built into the very much basic culture. As I said, DevOps is more concept, is a movement. The biggest change that is required, and the hardest one for DevOps really is the culture part of it. Because really, you're not working in a silo. You're not working as a dev or as an ops guy. We're not communicating with each other or hitting each other. So you really have to kind of start working with each other hand to hand from the very get-go itself. And that is the fundamental change and the biggest hurdle typically for companies adopting DevOps. As I'm talking to more and more customers and partners and developers, that's what I realize. That's their biggest hurdle. It's not that they're not able to come over it, but changing that mindset, shredding that meat, that, what, no, that's my traditional belief, that's my Old Testament, I'm going to stick with that. Letting go of that and going with the new way of things, which has seen a lot of benefits, is the key part here. Automation, as I said, everything. And when I say everything, I really mean everything. Not just your application source code, not just your POM XML. Those are basic minimal. Your test, your configuration data, your infrastructure, your provisioning, your scripts, your network settings, everything. I should be able to check out the workspace down from your Vagrant box up to your scalability, how it's going to scale, how many instances, what JDBC driver, everything should be available in the workspace. So there are lots of tools that enable that. We're going to talk about Docker, for example. We're going to talk about a little bit about Vagrant, and there are a lot of other tools people are using for reproducible test, dev, and production environment, which really reduces the impedance mismatch, and that's a fundamental part of it. Again, the reproducibility really comes from the fact that you have automated 100% over documentation. Anytime there is a documentation, somebody needs to manually follow a process, you're more likely to err in that case. And the last C really is the continuous delivery part of it. If you have all those aspects kind of covered, at least the third and the fourth one, the continuous delivery will come along with it, in the sense that you define, hey, I have a continuous integration already set up in my environment, where anytime anybody checks in, it builds out on a build server. Then you go to the next level. I'm going to do a continuous delivery where every commit to the workspace is a potential release candidate. Now, there's a beautiful book which talks about, how long does it take once you push a code to the repository, one single line of code, how long and how big is an effort to convert that push to production? That's what it defines, what your continuous delivery effort is going to look like. So essentially, as I said, DevOps has to be a happy marriage. It could be a grumpy marriage, but if it's grumpy, what happens in grumpy marriages? So it's a marriage of Dev and Ops working in tandem. That's a very important aspect. And you're going at the same pace. You don't go on your own pace. So you have to make sure you are as a team. As I said, it's a movement, it's a culture. So it's important to understand that aspect of it. How many have seen the movie Matrix, right? Yeah, we have all seen it. It's a classic one. And we love it. And I love this line from Agent Smith. Never send a human to do a machine's job. And why? Because, as I said, humans have feelings. If I tell you, can you run this database script, once, twice, thrice, 4 times, 5 times, like 3 times, maybe you'll do it. 4th time, maybe you'll do it to me as a favor. 4th time, you'll get grumpy. Why you keep asking me to run this script again and again? You're going to get the same result. Well, guess what? A Docker container or a shell script or a computer, which are very dumb but intelligent in the sense they can do repetitive tasks multiple times, are really good at that. So that's why there's a lot of emphasis in DevOps movement for automation as opposed to scripting it. You want to talk about continuous delivery?
Sure. So continuous delivery, we basically want to automate the full cycle that we can run. So everything from release, build, deploy, test, until acceptance should be as automated as possible. Typically, acceptance sometimes are still manual, but actually the end goal would be to actually have full acceptance tests that we trust that can be fully automated as well. So one of the really core features of continuous delivery is to fail fast and recover. And this goes back to when every step, even though every step might be automated, but still executed and started by a human, and the task is picked up by some kind of tasking system, etc. What happens if that fails is that the whole cycle has to go back and restart again, and it takes so much time. So what we're going to have is we're going to have a fail fast. As soon as we check in code, the tests are going to be run. It's going to be verified. It's going to be deployed and verified in different systems. It's going to be deployed and verified in different configurations that we have. So we can have different steps on where we run and how fast we fail, but that's crucial that we can fail fast and quickly go back to the developers. Fixing an issue when the developer was coding on it 5 minutes ago, it's a no-brainer. It's really, really easy. Fixing an issue that you worked on for 3 months ago requires reboots of your brain, basically, to go back and see what happened, what do you do in that case. So that's really, really, and the earlier we find the issues, the cheaper it's going to be to solve them, basically. So it's also about self-service. So this is to promote that we can actually have a culture of continuous improvement. So if people can actually try out different things and test, let's see what happens if I change this configuration. Let's see what happens this way. If we have a good continuous delivery environment, we can trust that those things, we can test them out and verify that the configuration change is actually improved or not improved. And we can have rules and steps and regulations saying which should we go forward, etc. So self-service is important. And 100% automation, as you talked about before, is crucial as well. It's not only about the time, if it takes 2 minutes or 15 minutes to deploy to a certain system. That's not core. The core is 100% automation, so that we can repeat the same step, avoid human mistakes, but also get back the feedback immediately, whether from performance tests, etc. For example, what happened when I enabled transactions in this? How much did I get any performance degradations from that, etc. So that's extremely important to have that automation fully. And the end goal is to be able to push to prod all the way automatically. That might sound scary for many how we're working, and we have toll gates protecting our projects today. But actually, if you think about it, if we can push to product in a couple of minutes, we might not be as afraid to actually go out with something that would actually have an issue in it as well. The problem is if we have 3 months release cycle, we better be sure that we don't have any bugs in there, because it's going to take us 3 months to fix them. But if we can fix a bug in 5 minutes, it's much more quicker for us to come around and do that. And to be able to trust that, to push to production, we need to proactively monitor and measure metrics here. So we get a trust from the organization, not only developer and operations, but also the organization and testers, etc. So that's a big step for some organizations, and that's why we say that culture is the most important thing about DevOps. But when we get to this automation with the correct tooling, we can actually go very, very along in this and changing the culture. And the benefit of that is we get an organization that can react faster to changes in the environment, changes to competition, etc. And that's what everybody wants, basically.
Right. One of my stories, for this is, I was talking to a guy, a friend of mine in Amazon, and he was telling me that, in order for them to go DevOps, I asked him, if an organization is looking to invest into DevOps, what is one thing that you would really, really emphasize on? And that was the last bullet. He said basically that, proactive monitoring and metrics. You can do whatever DevOps you want to do, but unless and until you're getting feedback on how successful you are, and you're getting alerts and logs, and you have a means to diagnose that, everything is futile. So just want to emphasize the focus of monitoring and alerts and metrics, which will define how successful you are. Now this is what we call as a continuous delivery maturity matrix. So if you see, on the left side we have all the rows: culture, organization, build and deploy. We have defined different aspects of what is there in DevOps. Then on the columns, these are the CMMI maturity levels. So initial, manage, define, and so on. Now, what we do is when we typically walk into a customer site or talking to a developer or to a partner, we say, guys, take a look at this maturity metrics. See, where do you stand? And then we help them assess, OK, this is where you sit in the matrix. So each row, you figure out what column, where do you fit in. And once you have defined that, then your eventual goal is to go from all the way to the left to all the way to the right. You might be all the way to the left. So depending upon, let's pick a release. Do you have a manual process to release? Say somebody have to manually push a button on it. Do you even have a POM XML where you can automatically release everything? If not, then let's see. Let's get you at that level. My classic story is, I was talking to a customer in India, and I asked them, hey, do you guys do CI and stuff like that? I said, CI what? I said, oh, OK, so we got to dumb down a little bit lower. So I said, how does your team really work in terms of releasing anything? Oh, yeah, we understand that. Well, we got 5 guys. There's a lead developer, and there are 4 other developers. The workspace sits on the lead developer's Eclipse workspace. And every time a release needs to be done, he right-clicks on his Eclipse workspace, exports the WAR file, and mails the WAR file to the test team. and the test team then tests it, hang in there, and if there's a patch that needs to be applied, he sends a jar file to the test team, then the test team opens the war file, applies the patch, and then they test it. And when they are done, they send that patch to war file to the production, which then goes into production. So the point is, initial, what I call as a level 1, but there are probably level 0 and level -1 for some folks that needs to be defined. And it's okay, maybe you are not aware of it, so we're not making fun of those. All we're saying is it's good to be aware and self-conscious about it. Where do you sit in this maturity matrix, and how can you grow it? Come here, man. I think he wants a picture. All right. You can learn more about the details of this maturity matrix on the blog URL. All these slides are going to be public, of course, sharing aspect. So the idea is to understand, just be aware of where do you sit in this maturity matrix, and progress from left all the way to the right. Let's switch topics.
What is Docker then? Well, Docker started as an open source project. It's also a company, and Red Hat is involved in Docker as well. But it started as a company focusing on creation, on software, created software used to create containers for software applications. So we also have to be careful about the word container sometimes, because we have the application container concept and the software. Containers in operating system levels is a bit different than containers on Java EE. And we'll go into why that is as well. And one of the core concepts is package once and deploy anywhere. Heard that before? Somewhere like build once, run everywhere. Yeah.
So like Java gives you Vora, write once, run anywhere. Yeah. And that's what basically these containers really give you. Or Docker. Docker is just one way of packaging applications in terms of containers. There are other like AppC and Rocket and things like that. Docker seems to be the most popular one right now. So really this is what it gives you. You can package your application per the Docker format, and then you can deploy them anywhere. In terms of the Java land, you have JVM that needs to be ready on that machine. In terms of a Docker, you need to have a Docker engine or a Docker host where you can run those Docker packages or Docker images. Now, if you show you, like in terms of, this is a script that we hacked up internally. It basically shows the top change sets contributed by an employer. There was this, I tweeted about this. This article was picked up. This tweet was picked up by InfoWorld, and then they made a big deal out of it in a positive sense, which is good. But the idea being, Red Hat is the biggest contributor to Docker after Docker, and that's 3 times the IBM or anybody else. IBM is the second biggest contributor after Red Hat, but in terms of Docker, we are definitely one of the biggest contributor after Docker in that sense.
Yeah. So with Docker, we can build an application and build a container in any language, in any tool chain, and package that into, that's what we call container. We package that into a set that we can then distribute and ship. And ship, we would call a Dockerized application, basically. And it gives you, the benefit it gives you is that it brings along all the dependencies that you need as well. For Java, it might not be so many dependencies, but if you think about other dependencies we have, like database connections and other things that comes into place, and Docker can actually handle that as well. There's a lot of dependencies in a typical Java EE applications we need to handle. And giving into that, we can then deploy it, and we can deploy the same container in QA or in production or whatever it is. No more opening up and micromanaging, replacing jar files in var files, etc. We package everything together in one container and ship that. And we can tweak a bit on how the container behaves by applying certain parameters, but basically that's how we can run it.
I think that's a very important aspect of Docker, where there is, if you need and if you want, there could be absolutely no impedance mismatch between your production, development, and testing environments, because that's the capability that Docker gives you. So you take, you define how your Docker image, so to say, the build-time representation looks like, which is down to the operating system, to the application server, to the database connection, to the JDBC driver, to the network setting, even to the level where you say how much memory, how much CPU it has going to be available to it. So you build the image, which can then be shared across a registry, which it's like, say, Thomas builds an image, shares it on Docker Hub, I download the image, and then I play with it, and then I run it. So, and the running part of it is the container. And I think that's the key word here.
Yeah. I think, and one of the things we have to remember, though, that even though container concept comes from shipping containers, of course, one of the things that we can actually scale those container software-based, we can scale them. It's what's in them that's the important thing, actually. So if you compare them to actual shipping containers, they're not fixed in size. But we can still use the concept to package them very, very tightly together and use them very well efficiently.
That's a great point, actually. And if I draw the analogy of shipping containers, long back, before shipping containers were invented, the idea was, there are lots of people who are producing all sorts of fun goods, car and bike and clothes and food and stuff like that. Now, they're producing in one country and they want to ship it to another country. So how would they do this? All right, so I'm a food factory. I'm going to produce the food. I have my custom package. I'm going to take my own car. I'm going to figure out how it's going to stack the best over there. Then I'm going to take it to the shipping company who has a ship, who don't know what to expect from what. Then they put that package in there. Oh, here's the food. Here's the liquid. Here's the cloth. Here's the car. They're all different sizes. Every time it's going to ship across through the different country, they're going to figure out a different scheme on how it's going to be the optimal way to do it. And you need a different kind of a vehicle, similarly on the receiving side, to receive it and unpack it and stuff like that. With shipping containers, that problem is solved to a heavy extent because the shipping company says, hey, here is my ship. On my ship, I can accept 20 containers. I don't care what the content of the container is. I've defined the measurements of the container. You can put whatever thing you want to put in the container. It's up to the car company, to the food company, to the Jello company, however they want to package it. But as long as you bring the thing back to me in a container, I'm going to do that. So it's a standard. So effectively, that's what Docker is doing, is defining a standard shipping container on what the runtime representation is going to look like. And what you package in the container is exactly your application-specific dependencies in that sense. So how is it different? The typical question is, how is it Docker different from virtual machines? So if you look at it, this is exactly from docker.com. This is like, let's say my host operating system. On the host operating system, I could have a hypervisor running. Say a level 2 hypervisor is VirtualBox. So on VirtualBox, I could run, this is a pretty decent machine. So I can run maybe 3, maybe 4 if I stretch really too far, 4 virtual machines in a parallel. But that's a full-blown operating system, Windows, Linux, whatever I want to run on it. It's a Mac, so on Mac, I can run those operating systems. And then if I want to run an application in a Windows environment, this gives me creeps, but if you want to do it on a Windows environment, then I can run a full-blown Windows on it, and then I have my application running on it if I need to. As opposed to Docker, where I have the same Mac. On the Mac, I have something called as a Docker engine that is being installed. So Docker engine is sort of the VM analogy that I gave earlier, JVM. So I have a Docker engine running here. On the Docker engine, all I say is, hey, you give me your Docker container, and I'm going to run the Docker container. Now, Docker, in that sense, is natively supported in Linux. So that's where the technology comes from. It uses a lot of those Linux features, like C groups and namespaces and all that. So in order to run on Linux and Windows, so you can run Docker on Linux and Windows, you need a tiny core Linux VM, which basically says, hey, you know what? Anytime there is a hardware and there is an operating system running on top of it, it has a lot of features already. So this tiny core Linux VM is a very tiny VM, which then emulates all those C groups, control groups, namespaces, all those features for you, and then talks to the underlying operating system to implement them. So all you have is a tiny core Linux VM, which is basically a Docker host on which you can run a Docker container. So to give you the analogy again, I can run 3 to 4 VMs at max on this machine here. I have run up to 50 Docker containers very easily over here, and not a problem at all. I never felt it. Yes, of course, it takes disk space. So for example, a virtual machine in that sense, a Windows virtual machine, a minimal virtual machine, you will have to have like 4 to 6 gigabytes, and that's just for the operating system. So you'll have to probably make a 10 gigabyte virtual machine, as opposed to Docker container, where the Docker engine is very minimal. I think it's about 400 megabytes. And a Docker container, which starts from the operating system with application server, with JDK, and the whole thing in there is not more than a gigabyte. That's the whole thing. So you have the entire stack, entire dependency baked in, and it starts up fast. So how does my Docker workflow look like? Well, effectively, you have this concept of a Docker client, which is the CLI, which is going to talk to my Docker engine or Docker host, so to say, which is where my Docker daemon is running. It says, I want to run a Docker image, or image is a build time. I want to run a container. Container is a runtime representation. Now, the Docker host doesn't have all the images. Docker Hub is the sharing part of Docker, as we were talking about earlier, which is where all your images are living. So the Docker client makes a call. It says Docker run blah, the image name. It talks to the local Docker host. On this one, I have a Docker client and a Docker host running on the same machine. But ideally, within your office setup or an intra-network, you will have like a Docker host running somewhere in a network, and multiple Docker clients can be configured to talk to the same Docker host. So your Docker CLI makes a request to the Docker host. Hey, I want to run an image. Docker host says, oh, I don't have that image, but I'll go talk to Docker Hub and download that image and query it. So it says, all right, I'm going to go look at the Docker Hub, what images are there. I'm going to download that image, and I'm going to run the container. Now, by default, it talks to the public Docker Hub, which is hub.docker.com. But you can easily set up a private Docker registry where you can install your private images. So as a matter of fact, Thomas is giving a lab later this week where we'll talk about how we have JBoss EAP, which is a commercial product, and where we have hosted where we have hosted private images or Docker images for JBoss EAP. So I think those setups are all possible. Now, as we said, you can run Docker host. So earlier, what people used to do is they would explicitly download boot to Docker, and then that's how you would run it on Windows and Mac at least. But Linux, of course, is natively supported, so you can fire up Docker IO, and it'll start up the Docker host for you. But if you want to run Docker host on a Windows or a Mac, which is sort of most of the developer population anyway, then you use Docker machine. So what you do is you say Docker machine. It's basically a script which you download from docker.com. And then you say create a machine. Docker machine works with a lot of virtualization providers, as they say. So in this case, I'm saying -- driver VirtualBox. It can work with DigitalOcean. It can work with Amazon. It can work with VMware. All those virtualization providers it will work with. So effectively, what I'm saying is create a Docker host on my local machine using VirtualBox as a virtualization provider. And I can do multiple of those Docker hosts. So if I need to sort of create a cluster later on, that's entirely a possibility. Then you configure your Docker client, talk to host. Docker is big on environment variables. Everything in Docker kind of goes through the environment variables. So you have multiple Docker hosts. You set up your environment variables accordingly. And then the Docker CLI is going to talk to the Docker machine or host, so to say, accordingly. And then the CLI will say, OK, well, I'm going to create and pull images. So let's say you're using a particular Docker machine, and you configure it to use another Docker machine. Those images are not transferable, so you will have to download the images again in that sense. You can start, stop, restart containers. And Docker 1.7.0. So today is the start of DockerCon as well, back in the US. I'm actually in the US, yeah, sorry. I was in London last week, so you forget where you are. Back in the West Coast in that case. So in San Francisco, there's the start of the DockerCon. So they're about to announce Docker 1.7.0. So for example, if you're running a Docker 1.5 or a 1.6 image, then you will say, oh, I want to upgrade the machine. So those capabilities all exist. Not recommended for production yet. So I think that's an important aspect. Docker is in a very early stage. A lot of people are using it, but it's still the Docker machine, at least aspect, is not recommended for production yet. It's from their website. And that's not something I'm cooking up, by the way. You want to talk about Docker Compose?
Absolutely. So there's also another tool called Docker Compose. And Docker Compose gives us the possibility to define and running multiple containers in the container applications, and we can configure that in a single file. So think about a typical Java EE environment. We have the application server itself. We probably have a database. We might have a web server in front of it with a load balancer, etc. And we might even have other external systems. So how do we set that up so that we can actually start those containers and they connect to each other? And Docker Compose can help us with that. Docker Compose doesn't add anything that Docker can't do natively. It's just a bit awkward to do all that through command line. So Docker Compose can help us to set that configuration up. It's great for development or staging or continuous integration, but it's not recommended for production yet. And this is how it could look like, for example. So let's say we have a MySQL DB here. It's actually called MySQL DB if you haven't heard it. But because it's created in Sweden, where I'm from.
So that's a good Swedish lesson for you guys.
And Me is actually his daughter's name.
Interesting.
So Maria was his other daughter's name. So that's why Maria DB.
All right.
So
And the daughters don't like each other anymore.
I think one left the nest.
Well, I hope it doesn't come back for DevOps.
No, exactly. So basically, we define a service called MySQL DB, and we have an image which we represent that through, so which is also called MySQL. And then we have a certain environment variables that we can control how that image is going to behave. So in this case, we set the root password, etc. We set which user to use, etc. And then we have the Wildfly container here, the application server. Could be EAP, by the way, for example. And in this case, we have Arun Gupta's image here. He created an image with Wildfly in it, and a MySQL driver, I would suppose.
Well, so in this case, for example, ideally, not ideally, typically when you start up, you are starting up multiple containers, a Wildfly, a MySQL, and so on, different containers. So you will fire up those containers on command line, Docker run, rara, you give a command, port forwarding, all those things. So you will start firing them up. But that becomes, suboptimal very quickly. As Venkat was saying this morning, it's like talking to a toddler. First time fun, but then you want to grow up. I want to talk to an adult. So it's okay for the first time so that you understand the command, but once you have understood it, then the goal is to put that in a Docker Compose file. So in this case particularly, the first service is MySQL DB. Well, I'm from the US, I'm going to say MySQL. So I'm firing up MySQL database. Then the second one is the My Wildfly image, which is a custom image because effectively these are running two separate containers. So I'm telling, and the last line particularly is useful because it says, MySQL DB, I'm linking the containers. The Docker has the concept of container linking. So you can link the containers. So there's a source container and a target container. So some of the environment variables of the source container are then available in the target containers. So effectively in this custom image, all I'm doing is I'm using those environment variables. The naming scheme for the environment variables is fixed. I'm using those environment variables, and then I'm creating a JDBC connection. So effectively, if Docker Compose wouldn't have existed, I had to fire up those containers, write a shell script, and then run that shell script. Now it's a one integrated tool where I say Docker Compose up-d, and it's going to fire up the container in a detached mode for me. It's a simplified version of that.
So let's take a bit of a step back. Why do I need to do that? Well, think about the Docker containers. We want to restart them and recreate them often. And also, they have their own IP addresses, their own host name, etc. Every time you create a new Docker container, it's going to have its own environment. And this is why it's important. If you link this, it knows in which order, for example, to start the containers. It also gives you the possibility to actually access from my Wildfly image here. I can access through the host name, DB in this case, because that's the last parameter here. I can access it will automatically translate that to the IP address that I have. So that's what's happening behind the scenes here, which is very powerful.
Now, Docker, as I said, so far we just had one machine, so that's all right. But typically you need a cluster of machines. You don't want to have a single point of failure. You want to run those Docker containers across a variety of machines, possibly across multiple cloud providers. So that's where Docker Swarm comes in. Docker Swarm, so to say, is native clustering for Docker. It says it takes a bunch of Docker hosts or Docker machines and provides a virtual host to them, sort of a single unified interface to all those pool of Docker hosts. And that's what it does. It's fully integrated with the machine. So for example, let's say you have 4 Docker machines. You can say put them into a Swarm cluster, and then your interface is just that Swarm interface, as opposed to talking to the individual machines. And machines can go in and go out of the cluster at any point of time, and that's completely dynamic in that sense. The advantage is Docker CLI, it's using REST API to talk to the Docker host. And Docker Swarm uses the exact same API. So all your tool that continues to work with a single host using the REST API will continue to work with Docker Swarm as well. It's partially integrated with Compose. I was looking at the Docker Swarm 0.3.0, which is literally released 4 days ago. I haven't seen any updates there yet, but hopefully it's going to improve. And again, this is not recommended for production yet. So if I were to kind of link up all these three concepts together and how is it relevant for DevOps? Well, Docker machine is basically a bunch of single Docker hosts that you can fire up rather easily. Docker Compose, if it needs to talk, you configure using environment variables which particular Docker host you are talking to. And as opposed to Docker Swarm, you're saying, oh, by the way, I'm going to take this Compose and I'm going to guide it to a Docker Swarm cluster. And in that sense, it just goes and talks to the Swarm cluster, which then internally talks to whatever machine it needs to talk to. Now, Docker Compose also has this capability by which you can say, take my service, scale it, scale down, scale up, and all those capabilities are possible. So it becomes fancy, specifically given you are running in a Swarm cluster. Now, in Swarm cluster, what you can also do is you can say, hey, I want to have different spreading strategies, how I want my containers to be spread across the different Docker hosts. So I have 4 Docker hosts. I want the containers to be maximum concentrated on one Docker host to begin with. I want the other containers to kind of stay idle. Or I want to have them spread across multiple containers. The standard Docker principle is batteries included, but replaceable. So they come with like those distribution strategies, but the goal is eventually, not there yet, but the goal is to kind of have your own mechanism by which you can define those distribution strategies as well. So what are some of the advantages of containers? And I thought we'll take this bullet one by one. So why did you start?
Okay, immutability. So creating a container and it becomes an immutability that we can carry between environments. So that means that we can be sure that every time we deploy that to different environments, it's going to work exactly the same, and it's not going to be changed or anything like that. That also means, however, that patching it, etc., means that we probably have to do a release of it, have to build it again. Just to keep that in mind.
And immutability in that sense gives you reproducibility, because the fact that it's the exact same image that is being used by everybody else, then you will continue to kind of get this exact same result every time you spin up that container.
Isolation. So containers are isolated from each other's. We can even control and make sure that they don't steal too much CPU. We can control that they are very, very secure in that manner. And they can't see each other's processes, for example. So if you go into a container and you list the processes in that container, you won't see any processes of other containers, etc. So that means they are very isolated. And we can even use it as using different versions of operation systems sometimes. Also, but there is a difference here. Virtual machines are isolated as well, but they are more heavily isolated. In Docker containers, the isolation stops approximately at the kernel level. So that means that we don't recommend you running, for example, running rel containers on another Linux distribution. You're probably going to hit issues eventually with that. It's not going to be supported, and you're going to have issues with that. And the reason is that sometimes we use kernel modules like SE Linux and other things that aren't there in the host operation system, for example. So therefore, it's very important to understand also the limits of these isolations. So with network, CPU, processes, etc., they're all memory are all isolated. But when you come down to kernel modules, etc., they're not isolated anymore.
Well, the big advantage of that is if one container goes rogue, so like, let's say you're running an application server per container, and if that application server is not behaving correctly, only that container is going to go rogue, because eventually you are limiting the amount of memory and CPU it can take. So it won't affect other containers, which is very important for making sure that your application is accessible and reproducible. Containers start up rather rapidly. So if you have to start up a virtual machine, if it's a Windows machine, then you fire up the virtual box, fire up the virtual machine, go get a coffee, maybe a lunch, and then you come back and say, oh, my virtual machine is up. That doesn't happen with containers, with Docker containers. You fire them up, the container itself is very lightweight. It starts up rather rapidly. Most of the time it takes to fire up your application. So it's a very efficient process in that sense.
So portability as well. So this is important. I worked at a company who were looking into these challenges quite long ago, 2 years ago. They were having a lot of issues in exactly that kind. And I think we all understand that there's a difference of the favorite server operating systems we're running in and the favorite desktop environment we're running in sometimes. But personally, my personal choice, I like Mac and as a desktop, but I want to use Red Hat Enterprise Linux as a server environment. And the problem with that is if I run locally in a fast development lifecycle, I can't test it on RHEL. And I don't like firing off a virtual instance, having to share screens, and there's also something that there's always something that doesn't work. If it's copy and paste or file transfer, I end up having to SSH into the machines, etc. So with Docker, that becomes seamlessly for me, and then I can run Docker containers on my laptop using Red Hat Enterprise Linux. It's almost seamlessly for me. I can still develop using my tools on Mac, but as soon as I issue that command, Docker run, I can run it on RHEL, and it behaves as it would on RHEL. And I can have all the optimizations that I have for RHEL for installing Postgres or my MySQL, etc. And then when I move this further, I know that I've been running this on this version of RHEL, for example, in a Docker container. When I move it further, I can be much more confident that it's going to work exactly the same in each environment that I go through. So that's portability for us. That's extremely powerful.
Right, because I think it gives a really huge benefit that I continue to be productive in the environment that I care about as opposed to the corporate pushing a standard on me. And then when I'm ready, I just say, you know what, here you go, here is my image, just go run it on the container. My wish list is in GitHub, I want an additional field where people can say, here is a bug, here is a Docker image, how to reproduce it. And that should be it. Because the Docker image, if you should be able to fire it, it should reproduce the environment for you, and then it should reproduce the bug for you as well. Docker also gives you the capability to snapshot as a particular image, if you made any changes to the runtime representation. So you can snapshot, and that gives you the ability, I want such and such version of my entire application. And then you can say, fall back on that particular snapshotted version. That's a possibility.
Yeah. Security Sandbox is a rather new feature in Docker, I think, but we have been working heavily with this, and Docker in RHEL is fully connected today with SE Linux. So the problem I talked about with kernel modules being shared, etc., it's not a security issue running on RHEL, for example. So we're very secure in not being able, in the isolation between Docker containers.
All right. We talked about how we can limit the resource usage as well. So you can say how much memory, how much CPU, and it doesn't go beyond that at all. And that's implemented using C control, the control groups feature I was talking about earlier.
Simplify dependencies as well. Yeah. So every time we deploy something, there's also, we talk about dependencies, but also actually dependencies in this case might be configuration for us. So configuration as well is one of those things. So if we can ship everything within one box, all the configuration, all the build code, everything we want, that makes it so much more repeatable for us to do.
And then sharing, of course, how you can make the same image and then reduce the impedance mismatch, which is a very important aspect of how do you do that in the DevOps land, because that's a critical aspect. So a couple of more concepts that we will share before we actually switch to the demo. So while in the Docker ecosystem, you have Swarm, Compose, and things like that, another important concept to understand, if you want to take your Docker to a production level, that's where Kubernetes comes in. And Kubernetes is an open source orchestration system for Docker containers. That's sort of a one-line definition of it. But effectively, you can take your Docker containers, run it in Kubernetes. I won't go into the details of Kubernetes. There are a lot of things that we can talk about it. But effectively, here are some of the key concepts of Kubernetes. The first one is the one that is most important, which is the self-healing capability. So effectively, what you do is you run a Kubernetes cluster, and that Kubernetes cluster can span across multiple machines. And then that's where it's running your Docker containers. Now, in a typical Java EE application, when you're running it using Docker containers, you will say, I want to run the application with at least 5 application server instances. Now, in a typical IT environment, you will run monit scripts, which is monitoring, if a server goes rogue, I'm going to bounce at the server again. So you do that yourself. With Kubernetes, you say, I want 5 servers. and Kubernetes takes care of it for you. That's sort of the desired state you define. And there are a lot of concepts in Kubernetes such as replication controllers, pods, which gives you that accessibility across a wide variety of hosts. Kubernetes automatically restarts the containers, schedule them across hosts to reduce a single point of failure. So same concept, batteries included, but replaceable. So won't dig into the details. The key part I want to highlight once again is in Kubernetes as well, just like Docker, Red Hat is the biggest contributor after Google. So Red Hat is the biggest non-Google contributor over here. And this is, again, one of the tweets that somebody from Red Hat did, and the article got picked up. So if you see here, Red Hat is the biggest contributor. This is a snapshot from Kubernetes project, literally picked up this morning. And you can see, Smart Clayton and Derek Wayne-Carr, those are the two Red Hatters who are number 3 and number 5 contributor to Kubernetes. Now, if we use Docker for all of our Java EE application, how do we test our Java EE application, specifically in the DevOps world? So here, Arquillian is typically what people use for testing Java EE applications. And Arquillian has introduced a new extension called as Arquillian Cube that allows you to test your Java EE applications as they're deployed to a Docker container. It uses the standard Docker REST API to talk to the Docker host. And then once it has figured out a connection with the Docker host, then it uses the container adapter to actually talk to the container that is running inside the host itself. For you, it's a very seamless process. But the way it works is, the first thing you do is you select a container, whether it's running on OpenShift or on Wildfly or Tomcat, whatever your choice of container is. Then it connects to the container. Then your tests, which are Java EE tests or unit tests, are deployed to the container. Again, running in the Docker, container is an overloaded term. So application container running in a Docker container, running in a Docker host. Feels like Inception sometimes. Where am I? Well, you run the test in container. You capture the results. And then you undeploy the archive, and you dispose the container. Disposable technology, that's how I call containers as, because they start up so fast, you don't mind disposing them because then you can fire them up again. And that's one of the advantages. I was reading a statistics for Netflix. The reason, and the 100% of their architecture runs on Amazon. On a given day, 35% of traffic of internet is Netflix in the US. And we watch a lot of Netflix. Anyway, but the key part is 70% of their images are recycled every week, and 90% of their Amazon images are recycled in a month. And that's what Docker containers give you. Amazon has support for Docker as well, but the point being, it's a disposable technology. You don't want to build technical debt over a period of time. You want to reduce technical debt, as a matter of fact, and that's what Docker helps you. You just dump the container, you start it all over again. So simple POM XML, you just need to add a couple of dependencies, first for the Arquillian Cube Docker, and then for the Arquillian Container Remote. Throughout the presentation, you will see URLs at the bottom of the screen, which will show basically, if you want to learn more about the technology, where do you go?
So
well, this is where we talk about the demo.
OK. So
well, let me set up the context.
Yeah.
Now, typically, when you are building an application, like in a Java EE application, you want to do a continuous delivery of Java EE application, then your application will have Fedora, RHEL, some sort of Apache, Wildfly, maybe JBoss EAP, Postgres, a whole bunch of combinations. Effectively, each of these could be possibly running as a Docker container. So what we're going to show you next is how we can do the impedance, reduce the impedance mismatch between dev, test, and prod environments. Using Docker, how is it simple to set up? Very repeatable. Isolation, we talked about it. Disposable technology, we talked about it. And lightweight. Before we get to the demo, the key part I want to highlight is on Thursday, we're doing a hands-on lab, which tells you Docker for Java developers. And then on Wednesday, we have a session where we talk about how do we use OpenShift and PaaS to accelerate DevOps and continuous delivery. We have a full end-to-end demo over there where we talk about how do you start with Ticketmaster, which is sort of the JBoss. Why don't you set it up? Yeah. Which talks about how do you set up your full Ticketmaster application. You do full DevOps using OpenShift v2 and deploy to different domains and achieve a full DevOps lifecycle or continuous delivery over there.
Sure. So let me first say, I was hoping to show you a live demo here. Sadly, I arrived late yesterday on a flight from Stockholm, and everything worked in the hotel, but coming here, the network doesn't respond anymore, and it doesn't work to go up to the Red Hat networks here. So I have some issues with that. So I'm going to show you a bit of recording. Actually, before I do that, let me show some of the things that we had from that demo. So let me show you the Docker Compose file. So my Docker Compose file, we're going to contain, is that visible?
Make the font bigger.
Can I make it bigger?
Yeah. There you go. It's better.
Is that better? So the first service I'm going to have was a Postgres, which was a database we're going to use. I had an image, which I created. I'm actually going to build an image here for that. And it has, so I had a definition of how my Postgres looks like. And it forwards only one port, which is the database connections. And then I had Sonar Cube. Sonar Cube can do code analysis. So I could send up code to Sonar, and it will go through that code and verify if you haven't seen it before, and it will run certain, make sure that we follow best practices, etc., and gives you not only it gives you a technical backlog of your code, which is kind of nice.
So now Sonar is just one aspect of it.
Yeah.
It gives you a static analysis of your code. But the point being, any of the functional integration testing, whatever you want to do, could be easily set up as a Docker container right here itself and fit into the entire continuous delivery lifecycle.
Yeah. I'm also using Nexus, because I want to build and I want to cache all the builds, etc. that I do. I want to actually, when I build stuff, I also want to publish it to Nexus.
And why is it important? One of the key aspects of DevOps particularly is you build the archive once. Unlike the customer I was talking about where you rip open the war file and put the jar file in there, you don't do that. No. There is one source of truth. You build the archive once, you never touch it. You even do an MD5 hash every time you verify it. You never open that archive again, because whether it's in test, whether it's in dev, whether it's in production, wherever it is, that's the archive, that's the single source that goes in there. As a matter of fact, it doesn't float around in email. That's where we check it into Nexus. Yep. We say, here are the coordinates, here is what you use for testing.
Yeah. And to tie it all together using Jenkins to automate the process of going through that. So Nexus has a link to almost all systems here, also a link to DevSys and Prod, which is running Yable's EAP. And just to show you, I'm using layering here as well. So my base image is based from RHEL 7.1. So it has some basic installations. It does a yum update. It installs Maven, Unzip, etc. A couple of other packages for us. That's my base system.
So this is your Docker file on how you're building the image.
This is my base Docker file. And then I layer this. And this is a nice feature of Docker. Docker has a file system that is a snapshot file system, basically. So what happens is that I build a base on this. And then if I have an application server, app server base here instead, I can build that from that base. So demo is my project and base. So I can build that from that. And that means that actually the disk space that I'm going to carry on here, it's going to reuse the same disk that I had. It's just going to record the changes I do. So the only difference here is basically adding Yable's EAP. So by building new images, I'm not actually tying up a full virtual system and a full virtual environment for that. So this gives me a possibility to add and do Yable-specific things that I have. So I can add some Java parameters that I want to use. I add the Yable's EAP, downloaded version of it I have here. And I unzip it, and then basically the last I do is I start it with standalone here. So it's all kind of very basic, but it gives you very good documentation actually. So code versus documentation, it gives you very good representation of what's actually going on, and layering on top of that. So we have different layers. Well, I think
that goes back to what Venkat was saying earlier. Is your code like a story or is like a puzzle? Here, I can just read it, and it basically tells me, oh yeah, you're creating this basic unique commands. But instead of saying somebody run that script, you just have a Docker image, and that does things for you automatically.
Yeah. So I'm going to run a recording of a demo that I have, and this demo is not using Docker as is the end container. The end container is actually, let me show you another slide before that, I think. Isn't that, oh, here we go. So it's using these components, using GitHub externally, using Jenkins and Nexus. Oh, sorry, should have paused that. And Nexus and Sonar Cube as well. And when I start this up, you'll see soon that this is the Jenkins interface that I'm using. So I start, in this case, I manually start one task here, but this could, of course, be triggered by somebody publishing to GitHub or something like that, or to your internal Netflix repo. And here we have the deployment pipeline documented again in code. So the first thing is going to happen in the build step is we're going to check out the code from GitHub, we're going to build and package it, and so that's happening right now. And then we're going to run integration test, and at the same time, we're also going to publish it was a bit quick there, to the Sonar Cube. So that means that we'll be publishing everything, we do some things in parallel. And in this case, just like starting a container, I'm only accessing OpenShift and starting a gear at OpenShift here. And what happened then is I create a release. A release will actually, it gives me the release number I'm going to use, and then it creates a tag, tagging the release in GitHub, and then it moves on. We build the artifact. So this is the end artifact we actually build based on that release. This is the last build we're going to do. We're never going to build anymore, because what's going to happen then is we publish that artifact to the Nexus repository, and finally we deploy the application to OpenShift and run it. So this is to see how that works. Looks like. It would look very similar to you if I were using Docker here. It would just be some different commands in Jenkins I would do. It's very automated to do. It's the automation of the infrastructure that's really nice here.
So I realize we're out of time already. So one of the things we're going to do is everything that we talked about in terms of how to use Docker for continuous delivery, for Java EE DevOps, we're going to release all that source code on the GitHub repository. And now stay tuned for our Twitter handles. Or JBoss developer Twitter handle. You will learn about all the information over there. I think we're out of time, but we're going to be hanging out in the hallway if you want to talk to us. Thank you.
Yep. Thank you.